Hey everybody, welcome back. This is going to be the second session of day 7, and we're going to go into our final chapter, which is network management. Let's go ahead and pop into that now. Looking at network device management, we're going to kick this off with an overview of SNMP. SNMP stands for Simple Network Management Protocol, and this is what we normally use for monitoring networks. This is fantastic for graphing and reporting. If I want to do a quick look at a router and I just want to validate that the interface is up, or I want to check for errors, that's fine, but the problem is looking at historical data. A lot of times I'll go to a customer and they explain that the network is running slow, or that there's problems, or that there's lost packets, and I always ask, what's normal? Which is a nice way to say, where's your baseline? In other words, if the network is slow or you're experiencing a lot of latency, what's a lot of latency? I talk to guys that work within the military, and with satellite links, you're going to see latency, I don't know, over a second, and that could be normal. If I had latency over a second, I would freak out. Like, for example, if I pop over here and I just want to do a ping to, I don't know, like here, I was just pinging Google, and I see my latency is 9 milliseconds, 17 milliseconds, 10. I could say ping 4222, and I'd say standard latency, you know, at least right now is 22 to 31 seconds. What was it yesterday? What was it a month ago? I don't know. So determining what's normal without logs or without historical data is really tricky. The nice thing about SNMP is we can create graphs and we can do reporting for lots of things, like CPU or memory utilization. We can look at things like interface utilization. We can look at things like dropped packet counts, and we'll collect all this data, and a lot of your SNMP tools will actually include alerting. So you can set thresholds. So if memory utilization or disk utilization or disk free space gets too low, you can have alerts go out. So we can use this for monitoring networks as well as managing servers. So just because they call it Simple Network Management Protocol, we could also use it to manage like a Windows server or a Linux server or anything else. The server that we see here is being referred to as a network management station, and this is where you would run software. So just reaching out to the 8 of you that are in class, do you use SNMP management or monitoring? And if so, what platform do you use? For instance, if Cisco could pick one, they would tell you to run Cisco Prime. And Mark runs SolarWinds, which is pretty good. Anybody else? Between Cisco Prime and SolarWinds, I would take SolarWinds all day. David takes SolarWinds as well. All right, so SolarWinds is an example of an SNMP network management station. This is the software that we would run, and then we define each of the devices that we want to manage. And for those of you that have seen SolarWinds before, you know what? I think they've actually got an online demo. Better to look at it than to talk about it, right? So let's just bring my browser tab over, and we'll say SolarWinds. And I'm pretty sure if I go to like Network Performance Monitor, demos, so guest, we go ahead and log in. Cool. So this is what it would look like with SolarWinds. You've got your overview, and then you can set up these tabs to monitor different things. You could look at servers, etc. Here we could look at we grab the network tab, and then here are all of our devices based on vendor. So we could open this up. They're just trying to demonstrate that they can talk to lots of different companies, whether it's Cisco or Avaya or 3Com or HP or whatever you've got. They've got the database to basically understand what all the MIBs are. There's different. There's a management information base that has specific IDs that mean specific things, like CPU or memory utilization. So it knows how to interpret all those. And then what you would see here is a list of all of your devices. So I could click here. Sorry, can't be loaded. There it goes. So here, for example, it's just a 6506. And we can look at some historical data. We can say, over the last 24 hours, what has our network latency and packet loss look like? What's going on with all of our interfaces? What's up and what's down? So everything we've been doing so far has basically looked like this. And I prefer the CLI. I love the CLI for configuration, but if I want to do any type of monitoring, this isn't so great, right? I can do like a show proc CPU, and I can take a look at utilization for the last 5 seconds, last 1 minute, and last 5 minutes. But what if I want to go back a little bit further? Where can I archive all of that? And what if I want to see graphs? If I look at my interface, I can say show interface serial 00, and I can look here and I can see things like my transmit and receive load, but what's it really doing? I mean, what's going on? It's got a 5-minute input rate, a 5-minute output rate, but what was going on 15 minutes ago? What went on a half hour ago? You don't really see those things from the CLI. From a graphing tool, we can look at this historically, which is much, much nicer and fantastic for creating reports from. So there's 3 different SNMP versions. Version 2 is the tricky one. You'll sometimes see V2 and sometimes see V2C. They're talking about the same thing. Once upon a time, there were multiple versions that were competing of version 2. Version 2C, which is based on community strings, which are just like a password, is the version 2 that won. So anytime we say V2, you'll sometimes see V2C. They're talking about the same thing most likely. So SNMP version 1 came out first, version 2 came out second, version 3 is the most recent. With version 3, they added support for confidentiality, integrity, and authentication. So here you had to basically authenticate. You had to prove that you were really the manager, except a community string is really just a password for doing SNMP. And that password is sent in clear text. So if anybody was able to sniff the network, they could see your community strings and they could break into the management interface to look at all of your routers. So SNMP version 3 is a version you should be using because it's secure. As far as obtaining data from an SNMP agent, you've got a network management station, and then you have SNMP agents installed on your switches, routers, firewalls, servers, and so forth. An SNMP graphic tool periodically pulls the SNMP agent, for example, a router, and then it generates data or retrieves data, and then it gives us a graph. So like right here, we can look at CPU utilization over time. Anytime we obtain data from the SNMP agent, we use a MIB, or Management Information Base. The MIB is a collection of information. It's organized hierarchically, and what you can do is there's actually MIB browsers. Like here they're just using a CLI utility called SNMP Get. There's another utility called SNMP Walker. And what you can do is basically browse the MIB database. So these are the types of things that we're actually querying for and then retrieving and showing the user. So if you wanted to do it by hand from a CLI, it's possible. I think I did this once or twice in a hacking class just to show people there's like Linux-based CLI tools. Once we steal the community string, I can query particular data using the CLI. And that's a little bit more hacker-like than just throwing a version of SolarWinds on your laptop. But we can query for specific things if we wanted to. SNMP configuration is pretty straightforward. You can create a read-only password and a read-write password. Read-only is obviously good for monitoring. If I want to pull stats and build graphs, the read-write capability you could actually use to make changes through SNMP. Not very common. Typically, we do all of our changes through a management tool like Cisco Prime or Cisco Configuration Professional if you want a GUI, or what we've been doing for the last 2 weeks or 4 weeks if you were with me for ICND1, which is using the CLI. Other things you can configure in SNMP parameters are a contact and a location. Don't underestimate these. Once your network grows and grows and grows, and you figure out that switch 37, if that was the host name of the switch, you might not remember exactly where that is. Well, if we put location information, this helps us track down the geographic location of an IP-enabled device based on a description. And then contact in a larger organization, if there's multiple people involved, this will let us know who to contact specifically if there's problems with that device. So here we're saying the community string is going to be Cisco, and that's going to be read-write, meaning you can use this for read, monitoring, or writing, making changes. So this is a pretty powerful setup. This device is going to be located in San Jose. Not the most specific location, but it's better than nothing. For a contact, they say talk to Joe Summer. So these are just examples of setting the device up for SNMP. We then go into SolarWinds or whatever your management tool of choice is, point to the device, and say that the community string is Cisco. All right, that's it for SNMP. Syslog is an equally important protocol. Whenever events happen on your router, they could be stored to a buffer, they could be sent to the console port, they could be sent to terminal lines. Terminal lines is another way to describe your virtual terminal, which is in other words, a telnet or SSH session for most of us. So we could have alerts go to the terminal lines, but what percentage of your workday do you spend logged into a router? If it's the majority of it, this isn't a bad place to send it. But if it's not, you might be in trouble, especially what happens at night, what happens when you go home, what happens over the weekends. We could be sending things to a buffer, but they'll be overwritten. We could send it to a console port, but no one's logged in. We could send it to a terminal, so if someone's remotely logged in, more likely than console they could see it, but still not optimal. Where you should be sending all of your logs is a syslog server. This can store it in a database, and then the database could be searchable. So some people use Splunk, which is pretty cool, but it gets pricey. I think you can only get about 500 megs a day of data for free. Another one that's out there, I stumbled into this about a month and a half ago. It's called ELSA, which is like Enterprise Logging and I want to say Services Engine. Let me just bring this up to show you what I'm talking about. ELSA is an example of a free, highly scalable syslog server. Enterprise Log Search and Archive. To me, this is kind of like a rough around the edges, but you see the word open source, free log aggregator. So this is kind of like a free version of Splunk, but not quite as capable. But still, there they are, just log. That's just their VM manager. There they are doing an installation of ELSA. It has a web interface. And basically all of your logs come in, it looks like this, and you can do searches against your logs. This is the same thing that not SolarWinds, but Splunk does. SolarWinds also has a logging engine, but depending on how much log data that you generate and whatnot, you could spend several $1,000s on it. Splunk could be tens of thousands of dollars. ELSA is completely free. So what is it? It's a Linux. You typically just spin up a Linux VM, give it a bunch of disk space. It's going to create a database, and it's going to start a syslog daemon. When syslog messages come in, it's going to archive those in the database in a format where it's searchable. And then we collect the data forever. We can hold it, I say forever, we can hold it until we run out of disk space. And the entire time, we've got a web interface to go in and do searches through our logs. This will blow away Kiwi or any smaller syslog servers you may have been using in the past. If you're running Kiwi and you think that's a decent solution, I beg you, check this out, or even grab grab Splunk and just control how much data you're sending to the Splunk box. And there's a free version. Splunk is pretty well polished, and a lot of people use it, especially in large organizations. It wouldn't be bad to get a bad tool to get some experience with. And in a smaller environment, it's going to be free. It's just chances are when you start using it and you see how powerful it is, you're going to want to log more and more data, and then that's where they want you to pay for it. Regardless, not everybody's on a limited budget in terms of purchasing software, but you want to have a syslog server. Like I said, ELSA is open source and free. Splunk is very popular. SolarWinds has a plugin. Cisco Prime has a plugin, and so forth. This is where basically just a service that collects all of our logging messages. When syslog messages are sent, this is a general format. You'll have a sequence number followed by a timestamp, followed by a facility and a severity. The facility can be used for basic sorting, and this is something that you can manage. So you might change this, you might hack this and say my servers have a facility of 5, my network equipment is a facility of 6. It's just for categorization. The severity, however, this is going to be on a score of 0 to 7, 0 being the most critical, 7 being the most insignificant. So 7 they call debugging level. And then this is, of course, followed by a description of what actually occurred. So a common logging message might have the date, and it'll say, line protocol changed to down, the line protocol and interface FA022 changed state to up. So we just had an up-down change. In this case, we just see an interface came up. Nothing too special there. As far as setting up syslog, it's extremely easy. You go to your server, you install SolarWinds, Splunk, or ELSA, give it a static IP address, and then we tell the switches, routers, and firewalls to send logs there. We need 2 commands. The first is the logging command that says where to send syslog messages, and then we say logging trap informational. Trap is a command that you normally hear aligned with SNMP, but in this case, they're saying what levels of messages do we send to the syslog server. If I'm using a syslog server, like Splunk, and I'm trying to stay under 500 megabytes per day of data, I might want to pick a lower logging level. So instead of logging at level 5, I might log at level 4. Remember, our logging messages are set up like this, and every single event that occurs on your router is going to basically occur at one of these severity levels. What I do to try to get the volume of logging levels of logging messages down is I'll log at a lower level, like 3 or 4. But that means I'm missing some things that I probably want at 4 or 5. You can come in here and get the exact syslog ID that you want to log, and then you can take that particular ID and lower it to a level 3. So you can basically reformat the severity of different messages. And this allows me to basically filter out a lot of things that I don't want. Alternatively, I could log at level 5 and then just monitor my logs. In certain events that are insignificant that keep popping up, I'll take that specific syslog ID and I'll move it to 6. So basically the event is still occurring and I could see it if I wanted to, but for right now, those messages aren't taking up space in my syslog server and they're not taking up any of my quota. NetFlow. How many of you are using NetFlow? Thumbs up if you're using it, thumbs down if you're not. And you can do a question mark in the room chat if you're not sure. That's a good answer too. A lot of people don't know. So NetFlow, of all of these protocols we've talked about, SNMP is cool, syslog is essential. NetFlow is amazing. What NetFlow is going to do for you is, let's just go through description. It's an application for collecting IP traffic information. So some people will say, you might come back to class, or you might come back to work after class. So maybe Karen put up a do not disturb sign on her door. She's got her office door shut so nobody bugs her because she's got her head buried in class. When she comes back out of class, they say around 4:30 Eastern time, the network got really, really slow. We're not sure why. What was wrong with the network, Karen? And she's going to go, I don't know, I was in class. I can check it out now, but now the network's running super fast. So you go, I don't know, it's a mystery. Problem's not there. If the problem arises, let me know. Well, NetFlow is information. A lot of times they'll call it IP accounting, but it's basically information about what was happening on the network. By comparison, if I look at my SNMP data, it would say port 13 on this switch had high utilization, and I could see that in a graph. And port 1 on my router was highly utilized. I know it was highly utilized. It's 72%. That's fantastic. My users told me it was highly utilized. What the heck was going on? NetFlow gives us what the others don't, and that's visibility into what's happening. I can see what user was talking to what server using which protocol, for how long, how many bytes were transferred. It's very much like your cell phone bill, where it shows you calls in, calls out, text messages in, text messages out, how long did the phone call last for? That's what it's giving us, detailed information about what's going through the network. Now, this is something that's not available on lower end switches, and I hate to use the term lower end on something like a 3750X, or I don't think 4500Xs do it either. Most of your chassis-based switches, like a 6500 or like a Nexus 7K should do it. Your routers are going to do it, not even fancy routers, and your ASAs will do it. So if you've got ASA firewalls, they'll generate NetFlow data. Do I need to pull this from everywhere in the environment? It depends how much visibility you want. Me personally, I just pull it from the edge device. So if I've got an ASA at the edge, I say, show me what's coming and going from the internet. And then this NetFlow data that is very, very detailed, it's up to you for how long that you want to log it. So like when we went to, let's pop over here. When we were looking at the SolarWinds site, SolarWinds has got a plugin for NetFlow. And what they can do is pull all this data about where people are going and how much data is being sent. So here we can see how much of our bandwidth is being wasted on YouTube, how much of our bandwidth is coming from our Oracle HR server. You can look at your top applications, web, SQL, NetBIOS name services, DNS, and then all of a sudden, we can look at this and we can become familiar with what's really happening within our network. What devices are doing most of the talking? Who are our top talkers? What are the top countries we're sending traffic to and from? What are the top endpoints? So when we look at these types of things, we can get an idea of what's normal. And then all of a sudden, if there's a spike, one day we've got 4 gigs worth of DNS traffic, we would know someone's either doing like a DNS, there's these new DNS, distributed denial of service attacks, that are creating like hundreds of gigs of data. We found one of our customers, they had a DNS server that was participating in that, and we wouldn't have known if we didn't have NetFlow. They have, I don't know, at least 3 gigabits per second going into the rack in the data center, and they're producing a couple hundred megs of DNS traffic. To them, that wasn't that much because they've got 3 gigs to burst to. They normally stay somewhere between 700 megs and a gig. So hundreds of megs of DNS traffic, they didn't even notice it. And without NetFlow, we would have never seen this. But using NetFlow, you can see trends like that and go, why on earth do I have, X amount of DNS traffic right now? What's going on? So it gives us visibility. SNMP gives you very broad utilization. And you go, hey, look, that interface is busy. Whatever. NetFlow gives us visibility into the actual content. So, David says his Nexus 5Ks don't have NetFlow. So that's unfortunate. Again, it just depends where you're trying to get that visibility. Most scenarios, I'm always coming into environments as a consultant, and typically I run a DEF CON user group of I think we just went over about 160 people. So most of the time when I get involved, it has to do with security issues, and those are the types of things that I'm looking for, and NetFlow is one of the tools that I use to find them. So really, really very cool tool. You could use SolarWinds to gather this stuff. You could use Landcope. That's another very cool tool. You could use Scrutinizer from Plixer. That's another decent one. And of course, Cisco Prime or HP makes a product called IMC. There's different people out there with NetFlow collectors. The NetFlow collector, it would be the software on a server that gathers all this data. And then the actual NetFlow agent or the NetFlow creating device would be like an ASA or an ISR or a higher end switch. And Karen, you have a performance team? That's pretty cool. You must work for a pretty big business. I know some of the folks that come through class are like, I go talk to the server team, and they're like, I am the server team. I'm like, talk to your database admin. He's like, I am the database admin. I'm like, talk to the help desk. He's like, I am the help desk. So you're actually big enough that you have a dedicated performance team, huh? That's pretty cool. And that's something that if you're in that team or building traffic policies, I'm sure this is some information you'd want visibility to. And again, what does it show us? If I didn't sum it up before, measures who's using network resources, and it's which network resources, how much of those network resources, and at what time. It gives us accounting and the ability to do chargeback for resource utilization. It uses measured information to do effective network planning. We've got real stats on the types of applications that are running, and it can use measured information to customize application and services. Or in other words, we can customize our quality of service policy based on traffic characteristics. Again, like I showed you, you can see things like top conversations and top applications. And the components are 2 pieces. You need a NetFlow-enabled router or switch or ASA and a NetFlow collector. Your NetFlow collector would be something like a Windows or Linux box, with some type of network management software on top of it that has NetFlow capabilities, like LANCOPE or Scrutinizer, Cisco Prime, SolarWinds, and so forth. NetFlow devices generate NetFlow records that are exported and then collected by what they call a NetFlow collector. Cisco's network analysis module, that's a blade that you could put into like a 6500. I think they've got one for the Nexus 7000 now, would be an example of a NetFlow collector. So you could actually have one that's hosted inside of a Cisco device. It also uses NetFlow data and provides results through the GUI. So the NetFlow overview, the types of values that you can get: source IP, destination IP, source and destination port, the layer 3 protocol, your type of service field. This is where we set our differentiated services code points. So to take a big step back, in your IP header at layer 3, one of the fields is called type of service. It's a byte. A byte is 8 bits. Eight bits, of those, 6 bits are used for differentiated services code points. So in other words, 1, 2, 3, 4, 5, 6, you could have something that looked like this. That would be a DSCP marking. What we do with IP traffic is we can mark it or set these values so that in times of congestion, we don't have to do first in, first out. FIFO, I'm sure everybody's seen this. This is your default queuing strategy. It just means that all packets are created equal, and whatever comes in first should go out first. In other words, if your executive is trying to make a phone call or a telepresence meeting to another executive, those packets are competing with BitTorrent traffic, spam email, and anything else. First in, first out isn't very good, but it's what you get by default. Using NetFlow, we can see what's happening with our applications, who's taking up the most bandwidth, who's getting stepped on. We're going to observe our NetFlow stats by collecting this data. Once we collect this data, we create our reports. We can tell which applications are more important than others, and we can set parameters called differentiated services code points that really live in the type of service field, which lives in the IP header. By setting these, switches, routers, and firewalls can see packets and realize that not all packets are created equal. Some are more important, and based on these markings, we can send those packets. That's the elevator pitch of what quality of service is, which doesn't really tie to NetFlow directly. We're just clarifying here that NetFlow can consider your type of service bits. And Mark says you use those for voice. Absolutely. So whenever your Cisco IP phone sends packets out, they should be marked with a DSCP of 46. If you added up that binary, it would be the number 46, which is a class of traffic called expedited forwarding. It means these packets are important and these need to go first. That's nothing that you need to know for CCNA, but it can be pretty scary stuff. I'll show you. It doesn't have to be scary. In my IP header for those ICMPs we sent earlier, and I guess I have two, you can come in here and you see you've got a differentiated services field of 0, 0. Well, if it were higher, if we had marked something, the value would be higher. It would be different. And then when packets come into switches or routers or firewalls, they have the opportunity to look at the DSCP field and say, okay, in times of congestion, meaning I've got 12 megabits of traffic and I've only got a 10 meg pipe, which packets aren't going to make it? Well, we can look at these DSCP values and determine what should get out immediately and what will go later if we've got room. That's it. So again, nothing that you've got to really know for CCNA, but stuff that's definitely good to know as an engineer. So the NetFlow architecture basically works like this. Routers are collecting data, and the flow collection software uses UDP to receive this data. So we export these logs to an external destination. Using NetFlow is going to probably give you a little bit of a hit on the CPU. So this is where SNMP comes in handy. We want SNMP, syslog, and NetFlow. These aren't alternatives. You want all of these. We'll use SNMP, and we will monitor our CPU and memory utilization. And we'll form a baseline. If the CPU and memory look healthy and good, then we turn on NetFlow and we start generating NetFlow logs. As we do this, we can continue to monitor CPU utilization and memory utilization and make sure that everything is working the way that it should be. Again, anytime we turn on additional services on a router, it's going to require more CPU and memory, and it's not always predictable. That's what makes SNMP so good. This is what we should set up on our router. Even if you just have a default route and you're natting traffic and you've got maybe a site-to-site VPN, fantastic. Use SNMP, take a look at your utilization. Then turn on syslog. Let it run for a day or two, and again, watch the utilization. Turn on NetFlow. Watch the utilization. Turn on Call Manager Express for survivable remote site telephony, and again, watch the utilization. What we want to make sure is that we don't max out the CPU. If the CPU maxes out, then we can't retrieve certain packets from the interfaces, then our buffers fill up, then we experience packet loss. We can avoid that degradation in network performance by leveraging SNMP and using baselines, just kind of monitoring for a trend and watching for increases. So to configure NetFlow, it's going to vary based on the version of code that you're on, basically. So my official answer is check the configuration guide for the model of device and the version of code that you're running. But we're going to configure NetFlow data capture and data export. This sends it to an external device. We'll tell it which version to use. There's multiple versions of NetFlow, and we'll verify NetFlow, its operation, and statistics. Mark says, what should your CPU be at to be considered healthy? I would worry about the spikes. It could always be at 70%, 24 hours a day, 365 days a year. And if it doesn't budge past 70, I probably wouldn't worry. Once it goes above 70, for me, that's where I get worried. And really, in most environments, it's not going to be stagnant. It's going to peak. So people will say, oh, we turn on these services and it's idling around like 50 or 60%. Is that high? I go, yeah. They go, is that bad? Not really. I go, but the thing is, what happens when there's a big sweep? And it always depends, right? If there's a huge surge in traffic, but it's just normal traffic that's being routed and it's all being handled by the data plane, nobody cares. If there's a huge surge of traffic and it's all being encrypted and the device you're using doesn't have hardware encryption, or the hardware encryption it has doesn't support the encryption suite that you're using, all that happens in software. So what could happen as traffic increases, CPU could increase, massively. But then in other situations, traffic could go from like 2% to like 70%, and you could watch the CPU not budge. It really depends what type of services you have and what you're doing to that data. Every environment's different. So really the thing you want to watch is for those spikes. So that's what I always say, turn on a feature, use SNMP, watch the device, and give it some time. You know how busy your network is, but network traffic is not predictable. New applications get rolled out. Some days, something significant happens in the news and everybody in the organization's browsing the web. So you just have to kind of give room for that depending on what you're doing, right? So if I'm using like iOS IPS, so I'm doing intrusion prevention using the router's CPU, it's not a big deal when there's low volumes of traffic. But when high volumes of traffic come up, based on the amount of traffic that I'm doing inspection on, it could become a huge load for the CPU. So you just want to watch for those trends, and it's the big spikes that we've got to watch out for. We don't want to have it ever spike and get into the 90s. All right, so your NetFlow configuration on this router looks like this. We go to the router and we say IP flow ingress and IP flow egress. This means we're going to generate data records for incoming and outgoing traffic. When we say IP flow export, that's to send this data that we're collecting here to this destination. So this is the IP address of my, let's say, scrutinizer box, just a Windows box running scrutinizer. And this is the port that it's listening on. You got to be careful with the port. I haven't seen much rhyme or reason with the port numbers, and they tend to be all over the place. So if you do the installation, the software might ask you what port number you want to use. Just make sure it's not something that's going to conflict with something else. And then when you set up your devices that are going to send NetFlow data there, just make sure the port number matches. Additionally, you can set the NetFlow version. And here they're just setting it to version 9. Look at your interface. If you do a show IP interface, you'll actually see your input and output features, and we can see we've got ingress and egress NetFlow data. If you do a show IP flow export, we can see the destination that we're sending it to, as well as the port number. In my experience, the port number can be problematic just because it's not standardized. So you'll just see if you're not getting data, double check that. And then additionally, if everything looks right and you just don't see anything, give it time. A lot of times your NetFlow collectors want to collect a certain amount of data before they start showing you stats on that data. So it might just be a process where it needs to run for 30 minutes before it generates any type of report or graph. You can view the graphs directly on the router. Here they're doing a show IP cache flow, and we can see the amount of telnet and web traffic that we've got. So we can get visibility from the CLI. You can use NetFlow without having an external tool, but tools like Scrutinizer are free for 24 hours worth of data. So I would never count on the CLI. I'll use it in a pinch, but I'd prefer to use a GUI tool just because the graphs are better. All right, so that got us through where we needed to get to for today. We described SNMP, syslog, and NetFlow. It's not a matter of choosing one of these. When we do network management, we want syslog, NetFlow, and SNMP. Syslog so that we can archive all of our logs and retrieve them historically. SNMP so that we can do monitoring and get good baselines of utilization. NetFlow so that we have visibility into our traffic statistics. All three of these are going to make your network much, much more interesting, I promise. That is going to be a wrap for today. Just look down at the time. So 6:51, we're doing pretty good. When we come in tomorrow, we're going to take a look at device management. So more device management. The entire rest of the class is device management, finalizing on the licensing. So if there's no more questions, that's going to be a wrap. If you've got any questions, as always, just stick around and I'd be happy to go over any concepts that you need help with. All right, looks like nobody's chomping at the bit for more data. I hope today was a good session. I got to show you guys some cool things. GRE is awesome. NetFlow is awesome. SNMP and syslog are pretty standard, but if you're not doing it, you should be. All right, so we'll go ahead and wrap up for today, and I look forward to seeing you guys tomorrow. Take care.